So this is a picture again of a queue, but this time our queue is implemented with a circular linked chain. So here we have chains where there is no technically beginning and end. In the traditional kind of linked queue implementation, we have a first node which points to the next, to the next, to the next, and the last node in the chain, its next pointer is null. And we also have a last node that points to that last element in the chain. So this is kind of your standard traditional implementation of a queue using linked nodes. And again, the last element in your queue is going to have a next pointer of null. And you're also going to have a last node pointer that points to that last element. So that helps you keep track of the front of the queue and the back of the queue. Well, in a circular implementation, you just have one reference, last node, and there is no next pointer that points to null. So it's a circular implementation because if we were to follow this chain, this next points to here, points to here, points to here, and we would just go around forever, right? So we don't have anything that points to null. So we can't use that to tell when we're at the end of our chain. And we also only have one pointer. We just have one reference to last node. We don't have a first node pointer. Now, it's very easy to get to first node. We can just say last node.next. Last node.next is going to be first node. Okay, so when our queue is empty, we're going to have last node is just equal to null. If we enqueue a single item, so we have one element in our queue, we set last node to point to that element, and then we also set that element's next pointer to point to itself. Okay, so this is what a single element queue would look like. And again, it is circular because the next pointer points back to this element. If we were to then add two more elements, again, here is our back of the queue, right? So our last node, and it points to the front of the queue, which points to the second element, which points to the third element. Okay, so the front is always last node.next. And so this is the first element in the queue, the second element in the queue, and the third element in the queue. Okay, so when we are adding things to the queue, we're going to add them to the back. We're going to add them to the last node position. And when we're removing things from the queue, we're going to take them off the front. Okay, so keep that in mind that last node is the back of the queue. That's where we'll be adding things. And last node.next is the front of the queue, and that's where we'll be taking things off. Okay. So we're going to write the code for this now. So we're going to start off, we just have last node. We just have that one pointer. Again, we don't have two. So when we initialize our queue with nothing in it, last node is just null, right? That's like this picture over here in C. Last node is just null. So last node. Okay, so let's look at the enqueue method. So to enqueue something, we first have to create a node. And when we first enqueue it, we will just say that the next pointer is null for now until we put it in the appropriate place. So the first thing we want to do is remember there's usually two special cases we have to think about when we're enqueuing something or adding it to the queue. We usually, two cases total. We usually have to think about what to do if the queue is currently empty. So if there's nothing there, that's usually one case. And then we also have kind of our just general case in case there are one or more elements that we're adding on to. So if our queue is empty, what do we want to do? Well, if our queue is empty, we had said we just want our last node to point to this new node, and we want this new node to then point to itself. Right, so we can say that our new node.next is going to be new node. So basically it points to itself. That's the circular part. And also last node is going to point to it. Okay. So now if it's not empty, so let's look at what would happen if we had something in there. Let's just say we had one element and we tried to add something on to this queue. So what we want to do now is we want to, remember this is the front of the queue, so we want to add something to the back of the queue. So we basically need to take this next pointer and make it point to our new node. And then what is our new node going to point to? It's going to point back around to the front. And then we again want last node to point to that new node. Okay, so one thing that can be helpful in dealing with circular chains like this is to declare a local variable, because otherwise the .next can get a little confusing. So locally we can say that, hey, well, our first node, I know that that's last node.next. And first of all, I know that there is a last node.next because I know that my list is not empty. So there's at least one element in my list, and so I know that last node.next is going to be it's not going to be null. Okay. So that's my first node. So what I want to do is when I'm enqueuing a new element, then my new node.next is going to be first node, right? So whatever new node I just created, it's now going to point at it's in the back. It's now going to be at the back of my queue. And so that means its next is going to point at the front of my queue, which is first node. Okay. And then I can say whatever used to be at the back of my queue, instead of it pointing around to the front, it's now going to point at new node. Okay, and then one last thing I need to do is I need to say, okay, and now this new node is the last one in my chain. So I need to make 3 reference adjustments here, right? I need to say that my new node, which isn't pictured here, and here we'll take a look this time, I'll use the picture in A. So if I had a new node down here, the first, let's say down here, because it's getting added off to the right at the back of our queue, I need to say that my last node.next now points to that new node. My new node.next points to my first node, and last node now points to the new node. Okay, so new node.next points to my first node, last node.next points to that new node, and last node now is the new node. Okay, so that's how I'm going to enqueue things. When I want to get the front of my queue, I can do this as I've done before. So I can say have a temporary variable front, and then as long as my queue is not empty, well, what is the front of my queue is in first node. So again, I'm just going to make a local variable first node, which is last node.next. And front is going to be first node.data. And I know that I can access first node.data because I know that my list isn't empty. So there's at least one thing in it. So I know that first node can't be null. Okay. So I can make sure my list is not empty. I get the first node, I find its data, and I return front. Okay, so now when I'm taking things off the list, so if I want to dequeue something, what if I wanted to dequeue from picture A? Well, that would be getting rid of the front of the queue, so I'd get rid of this guy here. So what I would need to do is I would need to say, well, now what is last node.next going to point to? Well, instead of pointing to here, it's going to point to here. It's basically going to point to the current first node.next, right? And my last node probably doesn't change. Okay, so first I'm going to, again, I need a place to store the data that's in that front node. And then I can make sure that my queue is not empty. And if it's not empty, I'm going to, again, get a reference to my first node, which is just last node.next. And I wouldn't have to do this. I just put this code in here because I think it's a little easier to follow. But I could always just reference last node.next instead. That would totally work. But just to make it a little bit easier, I'm going to say, hey, I know what the first node of my chain is. It's last node.next. And that's what my front data is, first node.data. And again, I know that I can invoke or I can access data because I know that first node can't be null because there's something in my chain. Okay, so now I know what that is. And so now I basically want to kind of get rid of that node, right? And so to do that, I'm going to say that my last node.next, instead of pointing to first node, it's going to point to first node.next. All right, so that's saying that this node here is going to point to here. Okay. And then at the end, I return my front. Now, there is one more thing I need to do when dequeuing. Remember, we always have a special case when we're enqueuing. We always need to think about what if we're enqueuing to an empty list, or an empty queue, rather. There's usually a different code for that. And with dequeuing, we always want to think about, well, what if I'm dequeuing from a singleton into an empty list, an empty queue? Sorry, I need to consider that as well. So what would happen if I was dequeuing here? I have my, let's follow the code we just said, right, where I get my first node, I update, I get the data from it, and then I update last node.next, right? So here I would get the data from it, and now I would say last node.next, which is this, is going to point to first node.next, which is also this. So I basically just reset my pointer to be the exact same thing. But what I really want now after dequeuing is I want nothing to be left in my queue. So what I can say in my code is that if my last node and my first node are the same, right? So if basically last node, which is this, is the same as last node.next, which is this, that means I currently have a 1-element queue, and what I want to do after my dequeue is have nothing left. So what I can say is, if after doing this, if last node equals first node, so if they're the same reference, that means that after my dequeue, last node should just be null. Okay. To test whether my list is empty, I can just return whether last node is null. If it is, my queue is empty. If it's not, there's something in there. And to clear my queue, I can just set last node to null. Okay, so there is a circular linked implementation, and at the bottom of this file, there's again some little testing code where we enqueue a bunch of things and then find the front and dequeue them. You can use that to kind of walk through the different queue functions. So here we add Joe, Jess, Jim, Jill, Jane, Jerry again, and we go through, make sure that each one is at the front, and then we remove them, front and remove them in the proper order. Then it's empty, and then we do it again with 3 elements and test the clear, and then again add and remove them, enqueue and remove them from the queue. Okay, so there is the implementation of a circular linked queue.